morning, everyone. Thank you for coming. My name is Luca Relandini. I work at Cisco in a European team that focuses on data center automation, orchestration, and cloud. This is not my first presentation on Contiv at Codemotion because I presented it already in Rome and Amsterdam. But those presentations were very basic, just to introduce the concept of the network policy model. Today, it will be just a little more advanced. I would like to show a real-life demo on my computer with a Kubernetes cluster and Contiv. Hopefully, it would work. In the other presentations I did, the demo was recorded. It was a sequential screenshot. I was a little coward. Now, I'm daring more. So we will see if it helps. Contiv is an open source project, so it is created by Cisco. It has been given to the community. It is available on GitHub, so you can go there, download it, use it for free. You can even help the development, so you can contribute to the evolution of the project. Actually, it is a networking plugin for all the container platforms, so it can work with Docker and the other runtimes, and it integrates with the resource managers like Docker Swarm, Kubernetes, Mesos, Nomad, and so on. So it has no linkage with the infrastructure. Can run on every kind of server, every kind of networking, any container platform, as I said. And it tries to make the life of developers and IT administrators easier. So they should be able to work faster and in a more integrated way, allowing for DevOps practices. So everything is based on a declarative policy model that should help developers to communicate to the infrastructure and the IT administrators what are their needs in terms of application architecture. So what components need to talk to each other, how they should be grouped, without just going into the technical networking details that generally are not very much liked by developers. In my professional experience, I've been a developer and a software architect, and actually I didn't like to talk to the network engineers or the IT administrators because we spoke different languages. It was difficult, and both parties were not really interested on the other party's need. So Contiv exposes tools and commands to both the parties to help them define the way containers can communicate. So ensure connectivity, security, eventually bandwidth in a data center across a large cluster of servers or in the cloud. So as I said, it integrates with the major, actually with all the resource managers. Some are not listed here, but they are, of course, supported. And integrates very well also with the physical infrastructure, so avoiding some problems that generally happen when you have an overlay network. It is certified by Docker. You can download it as a plugin for Docker from the Docker store. It's very easy to install. You see the command in the bottom right of the picture. It is also integrated with OpenShift and Kubernetes. By the way, that little picture in the corner comes from the DevNet website. DevNet is the developers community created by Cisco. So the URL will be in the last slide in the links. It contains documentation, tutorials, sandboxes. So there is a sandbox where Contiv is already installed with Kubernetes. It is ready to use. There is also a list of commands that you can exercise, and you can also reserve it for some days and use it as your private lab to do any kind of experiment. So I invite you to visit the DevNet website and play with the sandbox. So networking has evolved in the last 20 years. So you probably remember that it was very easy to connect physical servers to a physical network. You just needed to attach a cable, configure the port, and it worked. With virtual machines, we introduced an overlay network. So it is a virtual network running on top of the physical one. So you have two networks to manage. Sometimes they are integrated by a good solution. Sometimes they are two disconnected worlds that makes it difficult to do the right configuration, troubleshooting if something is not working properly. When you run containers eventually within virtual machines, it is even more complicated because you have three layers of networking: the physical one, the virtual machine networking, and the container networking. So there are some problems that affect connectivity. As an example, if you want to attach a load balancer or a firewall in the physical world to your networks where containers run, can be difficult. Encapsulation in each layer contains the other encapsulation packet, so every packet becomes bigger and bigger, and performances are also affected by this. And sometimes you have specific hardware with very advanced features that you cannot leverage when you are running on top of the three layers of the networking. So we should try to make this complexity easier to manage, and Contiv is a solution for that. Generally, this is a very simple application made of different tiers with a load balancer in front, a front end that could be a cluster of web servers, then you have application servers and a database. Over on top of the line, we see containers. In the bottom of the picture, you see a virtual machine. So you have networks that span different worlds. And of course, you could also have a physical server running another database and so on. So we want to stretch the networks and to allow the network administrators to work in a very easy way. Another problem is isolating microservices from each other, because of course a microservice is a collection of containers. We want to group them in such a way that they can communicate within the group, and we can apply consistent configurations to all the endpoints in that group without going one by one to do a local configuration of the network parameters for every component. So here a model comes to help us. It is called the group-based policy that Cisco invented also for other kind of technologies. It works in the physical networking, but it has been imported in Contiv that works the same way. Essentially, you define groups of objects. You see three groups in this picture on the right side: a web group, application group, and database group. They contain a number of objects that will be managed the same way. So you apply the configuration to the group, not to the single objects. And that helps a lot in case of horizontal scalability. Just think Kubernetes scaling your microservice to 100 containers, or maybe 1,000. All of the containers will inherit the same policies that we have applied to the group that contain them. So there is a command line tool to define policies. We also have a graphical user interface and REST API so that you can integrate Conti from whatever environment you prefer to work. So you can create policies, you can add rules, you can apply those policies to the groups. You will see that in the demo later. So the architecture, very abstract, is represented in this picture. Starting from the bottom, you see the physical infrastructure. You have network, servers, and storage. You have a number of hosts, node 1, node 2, node n, which are the cluster where you run Docker or any other container runtime. And you have the schedulers that allocate resources and manage the life cycle of your microservices through the containers. So Contiv will talk to the resource manager, helping them to manage the network. So Contiv itself is made by a central engine, which is the Net Master, that is deployed within Kubernetes, within Docker Swarm, and so on. Of course, managing also security and allowing to be multi-instantiated for high availability. And on every host, it deploys a plugin that works in conjunction with the OpenVSwitch that generally you have in Linux to provide networking to the containers. container networking for Docker Swarm is not complete because, of course, we should have all the lists. Sorry, I didn't correct this slide. So in Contiv, you can define tenants, which are partitions of the world that don't see each other. So I could have one tenant dedicated to a project, another tenant to another project. Those resources will not see each other. They will not create any side effect or conflict. So I can eventually create a network with the same name, same subnet, same default gateway in two different tenants. They will be two different networks. They will not communicate. So I can assign a tenant to a department of my company and another tenant to another department. They will be completely autonomous and isolated. Or I can give a tenant to each customer I am providing some kind of services. If I do hosting or infrastructure as a service, I can create tenants for everyone. Within a tenant, you create networks, policies, and containers. Networks can be attached to groups of endpoints, and the endpoints will contain a number of policies that are made of rules. So I can have 3 policies in an endpoint group, and every policy can contain from 0 to a large number of rules that we will see how are defined. So generally, you start working in Contiv, you create all the objects in the data model. So you create tenants, networks, policies, and groups. And then you go to your resource manager. In this case, it is Kubernetes, but could be Docker Swarm or the others. And you create your pods and services, attaching them to the networks or the groups that you have created. The link is made through labels. So when you deploy a resource in Kubernetes, you can apply a label to that resource, either if you do that from the command line or from the user interface or from a YAML file. So if you mention a group in Contiv in the labels, that deployment will happen within the group. And then, of course, you can use the two user interface to monitor and to manage the lifecycle of those objects. This is a graphical representation. So on the right side of the picture, you see the network administrator that creates the physical configuration in the network. In this case, we have a network fabric using the Cisco ACI infrastructure, but actually could be any kind of switch, any kind of networking. After the basic has been defined, the DevOps team, here we put admin as a name, but of course DevOps means working together, developers, administrators in a feedback virtuous cycle. So they work with Contiv, creating the policies, launching the application through the scheduler, as an example, Kubernetes, and making the policies to be instantiated in the physical, in the real world. Here you see examples of how the labels are applied to Kubernetes objects. So on the left, I am creating a replication controller pointing to a specific image that is Alpine, a Linux distribution, and saying Kubernetes to place that on a specific network, which is default net, and within a group, which is web group. So this deployment and all the replicas that will be generated will inherit all the policies that I have attached to web group. In this case, I am creating a new pod through a YAML file. In the demo, you will see that in action. And the new pod will belong to a tenant, which is blue, and will be attached to ContivNet, which is the network I have created. And this is the image that I'm going to deploy. This is the web user interface exposed by Contiv. It is very simple, and it exposes the same information and same commands that you can get from the command line. So you can go to the CLI and use netctl, which is the name of the tool to create those things, or you can go via your web to the console. So you can see a dashboard, the list of networks, the groups that have been created, network policies, and so on. So for every group, you see 2 kinds of policies that can be applied. Isolation policies, just for security, to isolate traffic from the endpoints and define who can contact them or where they can go, and bandwidth policies to reserve bandwidth for the traffic generated from those endpoints. So for important application, it is important to limit the consumption or maybe to reserve bandwidth for them. So in this case, in the web policy attached to the group that we named web group, we have two policies. One that allows TCP on port 80. The other one that denies TCP to everybody. So only port 80 is open in this case. If you go to networks, you see a number of networks that have been created, the tenant they belong to, the encapsulation. The encapsulation could be VLAN or VXLAN. Contiv can work in different modes, so you can create layer 2 networks, layer 3 networks. You can work in native mode, delegating the hardware to do the BGP and the routing. And it can also work in cloud environments. So you can deploy Contiv in virtual machines, in Amazon Web Services, it will work the same way. This is the Kubernetes dashboard. So you see a number of workloads that have been deployed. And we have some pods that have been created in the demo. If we click on Contiv C1 Blue, as an example, we will see the content. So this is the pod we are examining. There are the labels I mentioned, IO Contiv Network, Contiv Net, IO Contiv Tenant Blue, and a name for the application. And this is the container we have deployed in the pod. Contiv itself is deployed in Kubernetes as a service, Kubernetes service. So it is provided as a number of container images that need to be deployed, and they will be managed also in the same way. So if you go to a node in Kubernetes, which is named Net Master, it is where Contiv has been installed, and going down, you see the containers that have been deployed. So we have Contiv Net plugin, which is the core of the system. We have etcd to change the to store the key value information that is used to distribute the policies all across the nodes, and Net Master. Actually, Net Master is the central, and Net plugin is deployed on all the workers where you need to deploy the policies. Now it's time to go to the demo environment. Hopefully it will work. This is the screenshot for the authentication. I will run it on my computer. So the demo topology will be actually a portion of that, because I'm running too many virtual machines on this computer and power is not enough. So I have a Kubernetes cluster and a Docker Swarm cluster running here in virtual machines in VirtualBox. So instead of having one master and two worker nodes for Kubernetes, I only have one worker node, but it works the same. So in the master, we run the Kubernetes master and the Contiv master and etcd, the key value store. And on every node, we have the Contiv plugin on top of Docker, of course, and the kubelet to manage the life cycle of the containers and the services. So in the first demo I want to show you, I will demonstrate how tenants work. When you create environment, by default you have a default tenant. So everything is created in that tenant unless you specify the name of a different tenant. So you can create a number of networks and attach your containers to them. Then we will create another tenant called Blue with a name Contiv Net, which has the same name of this Contiv Net and same subnet and default gateway, but it will be a completely separate network. So containers that I attach to the Contiv Net here will never see the containers in the Contiv Net here. They are two completely isolated worlds. So the owner of every container is completely free to create all the resources with all the naming convention, all the networking convention that he likes, without no concerns, no worries to conflict with the others. And then we will create a tenant red with another Contiv Net network, Of course, you can give the network any name. I used Contiv Net to distinguish that from the native networks in Docker. But again, with the same subnet, same configuration as the others. So the objective is to demonstrate that containers in a tenant on a specific network can communicate among themselves, but cannot see other containers in a different tenant, even though the networks they are attached as exactly the same configuration. So it is a complete separation of 3 worlds in this case. And the second demo will demonstrate the groups and policies. So within only one tenant, so I am removing tenant blue and tenant red. I will only use the tenant default. I will create 2 groups of containers. One is called clients, the other one is called intranet, and then I can also create containers or pods, actually, since this is Kubernetes, outside all the groups, so in the open world, I would say. So all the containers in this group, outside of the group, and in the intranet groups are attached to a single identical network. So in this case, I'm not replicating the network in isolated tenants. It is one single real network common to everybody. But the separation is done through the policies that belong to the group. So group clients will have some policies attached. Group intranet will have other policies that you can see abstracted here. So deny all, so nobody can connect to these containers, but allow from group clients. So all the objects that live in this group will be able to communicate to these containers. So running web servers here, I can verify that if I run wget here, which is an HTTP client, to call the web server in here, I can connect to all the pods running in the intranet group. If I am outside the group called clients, I will not be able to connect. So the HTTP client will fail. How can I create this? Now we will go to the lab. I will create the network and the groups in Contiv. Then I will go to Kubernetes to run a specific pod. This is the name of the deployment. The image is Nginx, which is a web server on port exposing port 80, attaching 2 labels. -L is the short syntax for labels. And the 2 labels are IO Contiv network with the name of the network, default net, which is the basic one, and IO Contiv net group, which is the name of the group, so intranet group with 2 replicas. Then I will create the clients, one in the group clients that will be allowed to connect, and one in a different group or eventually without any group. The important thing is that the second client running Alpine is not part of the group clients. Then attaching to the 2 objects I have created, I will try ping and wget to the servers in the intranet group, and it will fail from the second client, but it will work from the first client because it is part of the clients group. Now let's try to make it work. So here I am connected to the Kubernetes Master node, where I can run the Kubernetes commands and the Contiv commands. So if we run kubectl get pods, there are no pods. And then we can go to Contiv, netctl. To see which networks do we have. So we have 3 networks in the tenant called default. Their names are Contiv H1, default net, and Contiv net. This is an infrastructure network, so used just to communicate between the nodes. those are usable from the deployments. They are encapsulated on the XLAN, and those are the specific configuration of the network. So this has been done already. If we go to netctl groups list, there are no groups, and we can also see the policies. There is one policy, intranet policy, that I created yesterday. Today I was trying to clean the environment. I wasn't able, something broke, so bear me for this. I will show how it is defined. We can see it from here. Inspect intranet policy. So this is the configuration of the existing policy that we will attach to the intranet group as soon as we create it. So there is a name. The type of policy is for endpoint groups. And there are 3 rules. We can also go to the user interface and see the policies from here. Probably I need to authenticate again. Yes. Okay, so we already have 3 networks, the same that we have seen in the command line. Contiv net, Contiv H1, and default net. We have 1 group attached to a network. We can see the isolation policies. So we deny TCP and UDP, and we allow TCP on port 80 just for containers running in the group clients. When you create a new policy, you can create any combination of from and to sources, and from groups or from network, and specify the protocols or a pattern of IP addresses. We have no bandwidth policies attached here. We can also see the list of policies existing in the system. So now we will create some new objects. I will copy the commands because I want to avoid that I don't remember all the parameters and I failed the demo. So I will, this network is existing already, Contiv net. So I will create the 2 tenants. And now we can see netctl tenant ls. Now we have 3 tenants. We have default, red, and blue. Then we can create the networks. As you see, we are specifying the name of the tenant, tenant blue and tenant red, with identical subnets and gateway and name. But they will be 2 different objects because they are bound to the specific tenants. So now we can check. Okay, they were not shown initially because I executed net ls in the default tenant. So it only showed me the 3 networks in the default tenant. When I added dash all, that means all tenants, I could also have specified dash T blue or dash T red to see the networks only in that tenant. I see the full list. So in the tenant column, we see red, default, 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 and blue. So if you check, the configuration is the same, but they are separate. Then we will create 3 containers, 3 pods actually, attaching them to the different networks. We can go to the file to see what's in it. So they're here. So inside Contiv blue, C1, that is to create the first pod. We have kind pod, the labels. So we are attaching it to the blue tenant on the Contiv net, and we are running Alpine. And if we have a look at the red one, it is identical, but it uses the tenant named red. So we can use kubectl create. We are creating another one, and the blue C1. You see, they are already running, that we have the 3 pods, and they have got an IP address. So the first 2, in the 2 separate tenants, in the blue and in the red tenant, have the same IP address, but they are not conflicting. Now we will attach to one of them and see if we can ping Contiv red. So let's attach to the tenant, to the pod. We will start with Contiv blue. Now we are running the command line inside the operating system of that pod, one instance of that pod. So we can ping 3 times. So we said we are in tenant blue. We have this IP address. We would like to test if we can reach this IP address. It is on the same network, but it is a different network because it is in the red tenant. So it is not able to connect. It will time out. Okay. Now we attach the other pod. So now we enter in the red tenant, and we try to ping the same IP address. It works. So we have demonstrated that in this situation, we have this container that cannot ping this one, but this container can ping this one, even though they have IP addresses that look similar, because you see them here. They seem to be on the same network. So the second test we want to do is this one. Remaining in a single tenant, creating 2 groups, applying policies to the group to segment the traffic and allow only the group clients to contact the intranet. And this one will not be able to do that. So we can remove all the assets that we have created. I cannot delete the networks because there are pods or still attached. So if I check the tenants, we only have default. Groups. Group. We already have the intranet group. I don't know why I'm not able to remove that. There is some remaining of my test that I did yesterday, so I wasn't able to remove all the resources, and now I'm not able to remove it. So we will consider that this group is already existing, but we will apply the right policies and make it work. So if we go back to the user interface, we have the default network and Contiv network. We have only the internet groups. We will create the clients group. Actually, we can also do that from here. It will be in the default tenant, the only one I have. And we don't apply any policy, just create a container for a group to contain our containers. I think it should be Contiv Net, just want to check. Contiv Net, yes. So this is the way to create the same group from the command line. Net control, group create, name of the group, and the network it is attached to. So if I do that from here, I will attach it to Contiv Net and create. So it has been created. Hopefully you can read it. We have clients and intranet. In clients, we don't have any endpoint because it has been created just now. No? There is one? Okay. No endpoints found. It was a old data that was refreshed now. And in intranet, we have some policies already applied that deny TCP and UDP traffic, but allow TCP on port 80 just from clients. So this has been created already. This policy is existing because I was not able to remove it. The intranet group is there already. Now we are going to create a deployment with a web server, Nginx, exposing port 80, and using the two labels that we already know. So IO Contiv network, Contiv net, and IO Contiv net group, intranet. So we are placing that in the intranet group. Okay. It is creating. They are running. Now we can create the clients. So we will create an authorized client because it is in the group clients, and one that do not belong to the group. So it's outside any group, so it is not part of the allowed word that can connect the intranet. Okay. From here, we should be able to connect to the intranet. So if we run the command, we should have checked with what is the IP address exposed by the servers. So not sure it is the one I copied here. We will go. So we want to contact one of these two servers from the client that we have created. So I will copy the IP from here. No, I need to attach to it, sorry. Okay. Now we can ping it. So see if the ICMP protocol is allowed. And we can try to make an HTTP call. Doesn't work. See what are the policies that we applied. We are allowing TCP on port 80. Yeah, it's reverted. So we are short in time, so that is the problem. They have been created in the opposite order. So I will skip this, and we can create the other client. It is called ROG. Let's change the name. Okay, time to go ahead. Sorry. I expected that something in the demo wouldn't work. So we will go quickly to the conclusion. I would have tested the same on Docker Swarm. I had the environment ready, but we are unfortunately late. So creating 3 groups and the policies with deny all and allow from group clients and the deny, and I would have tested the same cross communication that we have tested already. Those are the instructions I would have used. With Docker, it is a little different. You create the net control group with the policy, assigning it a tag. Then you use the same tag to announce a network in Docker, referring an option and the driver for Contiv. And then you create the services using the group as the network name. So we need to close. I'm sorry I couldn't show everything I wanted to, but I hope you appreciated the value proposition. It is a policy framework that allows to apply configuration to large groups of objects. So you can create a group, and all the containers and microservices that runs in the group will be managed applying the same configurations to them. Security policies for segmentation of the network, and bandwidth policies to ensure that every application has the proper amount of traffic allowed. It works with Docker, but also with the other runtimes, and integrates with Swarm, Kubernetes, Nomad, and Mesos. It has no constraints on the infrastructure, and from the benchmarks we run, we have got exceptional performances when compared to other plugins that you could use in the same environment. So Contiv is much faster and performant than Caligo and Weave and Flannel and the other virtual networks you can run on those environments. If you want to try it, it is on GitHub, so you can go there, download it. There is documentation, source code, and binaries to install, and there are a number of links here that could be useful. This presentation will be shared after the event, so you can go there and find it. Actually, we thought to create a user community in Italy, so to understand if there is enough interest to dedicate resources to that, I created a survey to collect your interest. So if you are interested in the community, we could potentially create, please go there and vote for it. It is very, very simple, just to count how many people would be participating.